Okay, let's go through it. Talk me through it. So what did you do first? Tell me what you did, please. So cosine of x plus sine of x times sine of x over cosine of x equals 2. Good. Then you got a common denominator. So that's cosine squared x plus sine squared x all over cosine of x equals 2. So that's 1 over cosine of x equals 2. So that's secant of x equals 2. Now we can look at this a lot easier, right? If we just think of it as secant is the reciprocal of cosine, right? So we would think of this as maybe easier cosine of x equals 1/2. And where does that happen? In two places, so we'll have two solutions here. Pi thirds and 5 pi thirds. Very good. Plus 2 pi, and we can do that as many times as we want. Very good. You guys are awesome. Way to do that. Okay, anybody have any problems with problem number 17 on the homework? Or were you all able to get the same as the answer at the back of the book? Or do we need to go over it? Okay, let's maybe do one. So number 17, so we would isolate sine. So we'd add 1, divide by 2. So we have sine squared of 2x equals 1/2. We'd square root both sides. So sine of 2x equals the square root of 1/2, which is root 1 over root 2, which is the sine of 2x. When does that equal root 2 over 2? Because I'd rationalize, right? Because that's 1 over root 2, and that's root 2 over 2. So that happens, and we can't forget, we actually already forgot, I already forgot, when we took the square root of both sides, we needed plus and minus, right? Okay, so there's a lot to think about. This one was probably one of the more advanced ones, just because there's so much to think about. So we're actually going to do this. When does sine of 2x equal positive root 2 over 2? And we're also going to do when does sine of 2x equal negative root 2 over 2? So let's look. That happens here and here for this one, right? Guys? Yeah. So we have pi fourths and 3 pi fourths. Now we have to be careful here in just a second. And then we have negative root 2 and negative root 2 over 2 is what I meant to say. So for this one, we have 5 pi fourths and 7 pi fourths. Now, in the back of the book, you'll notice these two aren't solutions. And you'll notice, so that's just 2x though, right? That's just 2x. So, but I want to stick to this, let's see, how do I want to explain this? So we have 2x is equal to, we know that we have 2x is equal to, 2x is equal to. Okay, here is what happens, is the back of the book, instead of doing plus 2 pi n, they say plus pi n. Now here's why. So those are all technically solutions, yes. That is true. Everybody agrees. Now here's the thing though. If we just list out these two solutions, sorry, I'm going to keep those circled for a second. If we just have those two solutions on an interval from 0 to pi, are those the over the interval, are those the first two solutions? And then look, from those, if we add pi, won't that take care of that solution? And then if we add pi, it will put us back here, which is good. Add pi, so we, instead of adding 2 pi, we can just take these solutions and add pi to them. So we don't have to list out these ones. That's like double kind of listing them. Because look, if we just add pi to this, that'll put me there. If we add pi again, puts me back to there. Add pi, add pi. So like these are solutions, but we don't need to put them. It's kind of like double dipping. So we would say pi fourths is our solution plus pi, and 3 pi fourths plus pi is our solution. But now we'll divide, now we have to solve for x. So we would multiply by 1/2 or divide by 2. So I'm just going to go like this. Multiply both sides by 1/2. So our final answer in the back of the book, we would distribute 1/2 through. So that'll be pi eighths plus pi halves n. So x is equal to pi eighths plus pi half n. Does that make sense, everybody? That was a hard one to think about. And then we distribute 1/2 through. So x is equal to 3 pi eighths plus pi half n. Okay. That only happened because our solutions were in all 4 quadrants. if that makes sense. Because normally they're like not, and so then it's just listing out plus 2 pi for sine and cosine. Okay, awesome. Okay, so write these down really quick. I wanted to give you a paper with them on, but I never got to printing one out. So we're going to be using sum and difference formulas to take something and rewrite it so that we can simplify it using the unit circle. So last time we were solving using the unit circle, now we're going to simplify using the unit circle if possible. So you can take something that's sine of u plus v, so sine of u plus v is the same thing as sine of u cosine v plus cosine u sine v. And then you can simplify it in sections. So if you have sine of u minus v, you can rewrite it as sine of u cosine v minus cosine u sine v. And then you can simplify it in sections once again. Cosine of u plus v is equal to cosine of u cosine of v minus sine u sine v. Cosine of u, v minus u. Anyways, I don't need to read them because you're probably writing them down. So I'm just going to let you write them down, and I'm going to give you a way of a trick to help you remember these. Kind of trick, a dumb trick. Right, because I have to do this kind of thing to help me memorize. In math, there's quite a bit of memorization sometimes involved. So with sine, splitting up sine of u plus v, notice that your sines are on the outskirts of town and your cosines are on the inskirts of town. And then notice it's just sine of u comes first because u was first here, cosine v, and then it will be cosine of u, sine of v. So then, and notice the sign, if it's plus on sine, it's plus. For sine, if it's minus, the signs are on the outskirts of town, the cosines are on the inskirts of town. You're right, that kind of sounds not appropriate. You're right. Yeah, you're right. There's a lot of things. True. Okay, I'll try to come up with a different saying. Okay, but notice then cosine's kind of weird. Cosine, the plus is opposite, minus. Right, everybody? And then cosine comes first and then sine comes last. So cosine's negative, so cosine will be opposite, plus, and then cosine comes first, sine comes last. Then notice with tangent, it's tangent of u, so well this is plus, so this is plus. So tangent's plus with plus, minus with minus, and then on bottom it switches. So 1 minus tangent u, tangent v, and whatnot. It's just memorizing it, looking and figuring out how can I memorize it. You know what I mean? But I was just trying to memorize them myself. Okay, so guys, what sum and difference formulas do is they allow us to possibly rewrite a sine or cosine or tangent function so that we can find exact values using our unit circle instead of giving approximate values. So our goal is to rewrite it in terms of our special angles from the unit circle, in terms of 30, 60, 45, 90, and whatnot. And then you can use your unit circle to simplify it much easier. Well, to get exact values instead of just, you'll see what I mean. So, for example, if I said to you, find the exact value of cosine of 75 degrees, you can actually take and rewrite this. So, notice right now you're like, well, that's not a special angle on my unit circle, correct, everybody? But we can actually take and rewrite this as a sum or difference of some special angles we have. So you do have to just use your brain a little bit. Isn't this the same thing as cosine of 75 degrees is the same thing as cosine of 45 plus 30, correct? So now looking at it, it's the same thing. So now we can nicely simplify this, getting exact values here. So we would rewrite this as using our formula. So this is the same thing as cosine. Remember, so let's try to memorize it. Cosine is cosine, cosine, opposite sign, right? So if it's plus, it's going to be minus. So we'll have cosine of 45 degrees, cosine of 30 degrees. Sine is opposite, minus, then sine comes next, sine of 45 degrees, sine of 30 degrees. And now we can just use our unit circle to simplify it and get exact answers. So cosine at 45 degrees is root 2 over 2. So we have root 2 over 2, we simplified that, times cosine of 30 degrees, so cosine's x, so times by root 3 over 2, minus sine of 45 degrees is root 2 over 2, and then times sine of 30 degrees, which is 1/2. So we have root 6 all over 4 minus root 2 over 4. Because they're a common denominator, we can combine them. We can't combine radicals unless they're like radicals. 6 doesn't simplify. So we have root 6 minus root 2, which can't be combined, all over 4. This is an exact answer. Whereas if we just type it into our calculator, so I want you, for fun, for me, type in cosine of 75 degrees, hit enter.
0.32.
You got 0, I want to write it down, 0 point, oh, you're just making it up? 0.25. Because we got to look, when you multiply straight across. Yeah. Okay, now watch. We can check our answer because this is the exact answer. This is the decimal answer. Literally type in square root of 6 minus square root of 2, hit enter, divided by 4. I know, I keep thinking of something. I kept looking back there. Guys, do you see how it came out the same? Okay.
Yeah.
Okay, let's do another one. So it says, find the exact value of sine of pi 12ths. Once again, pi 12ths is not on our unit circle, but can we take one of our radians or a couple of our radians and somehow either add them or subtract them to make them pi 12ths? You're going to have to get creative. You have to use your brain for these. Can anyone think of anything? Not quite, but it was a good thought. Pi 6 and pi half. They do. We could get them to be 12, but then that doesn't be 1. You could try that. So pi half minus pi 6. But then if we get a common denominator, this will be 6, this will be 2. Won't it be 4 on top? So we need it to be 1 on top. What can make us 1 on top? 4 and 3. Pi 4ths and pi 3rds, right?
Yeah.
Now we need it to be positive 1, so pi 3rds needs to come first. So look, guys, pi 3rds minus pi 4ths. If we were to actually do that, that's going to be pi 12ths. See, look. We would get a common denominator, 4 over 4, 3 over 3. So it did take some thinking. It does take some thinking. It's not just straightforward. So that'd be 4 pi 12ths minus 3 pi 12ths, which equals 1 pi 12ths. So we do use pi 3rds and pi 4ths, which are on our unit circle. So we can rewrite this as sine of pi 3rds minus pi 4ths. And now we can find the exact value of this because we'll split it up. Now remember, sine is on the outskirts of town. So we would have sine of pi 3rds and then cosine of pi 4ths. Sine stays the same, so it'll be minus. And cosine's inside, so cosine of pi 3rds, sine of pi 4ths. And now we can just simplify it in sections, which is nice. So sine of pi 3rds is root 3 over 2. Cosine of pi 4ths is root 2 over 2. Minus cosine of pi 3rds is 1/2. Times sine of pi 4ths is root 2 over 2, and now we're finding exact values rather than a approximate value. Root 6 over 4 minus root 2 over 4, I'm multiplying straight across, so we get the root 6 minus root 2 all over 4. Yep, it is the exact same thing. But it was just a different way of looking at it. It was like in radians. It was in radians rather than in degrees. Everybody good? So it almost would have been easier. It's like easier to almost think about it as degrees, right? So couldn't we have changed pi 12ths into degrees and then thought about it a little bit easier? Way easier, right? Okay. So I don't mind if you do that. Okay, next thing it says, find the exact value of this. Notice none of those, 42 and 12, are not on our unit circle. So we can't do that. But we would recognize, oh, this is a sum or difference formula. It's sine, right?
Yeah.
So this is the same thing as this must be u, this must be v, this must be u, this must be v. So this is the same thing as sine of 42 minus 12. So this is the same thing as sine of 30 degrees, which now we can find that. Sine of 30 degrees, boom, 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 is 1/2. Right, sine is what? So it's really easy. A lot of times on the ACT, they'll give you the formula And they'll say, so what's this? So it's just knowing how to use it. Yeah, you would have been like trying to actually do the decimal and yeah. So it's just recognizing, okay, I can change this. Okay, this one's a little bit more advanced. Here we go. You're going to have to think back to when we were dealing with inverse of sine, inverse cosine, inverse tangent, and what that means. So that means we have an angle whose tangent's this. And those have restricted outputs, right? Arc sine, arc cosine, and arc tangent. Remember, just a reminder real quick, for tangent, our outputs are going to be in these two quadrants, positive pi halves and negative pi halves, tangent, right? Then sine, for inverse, so I should say tangent inverse, sine inverse will have outputs, once again, in positive pi halves and negative pi halves. That's where our answers are going to be, as in these two. And then for cosine inverse, it's actually the top half of the graph. Our outputs are from 0 to pi. Okay, so we're going to evaluate this. I'm going to push pause real quick. Okay, so we're going to notice this is a sum for a cosine. So we can rewrite this in pieces. So we would have, now this is going to be, guys, this is our U, and this is our V. So we've got to show our work nice and pretty here or we'll get confused. So we're going to rewrite this. Instead of having this, we need to have this. So we can evaluate it. So we're going to have, with cosine, we have our cosine of the front thing. So it'll be arc tangent of 1. And then we have cosine of V comes next. So then we have times cosine of arc cosine of X. And then opposite is cosine, so minus, yikes. And now I'm going to have to kind of, smash it in. So we have minus sine of arc tangent of 1. And then times sine of, sine of arc cosine of X. Yikes. Hate that. Hate that it's all squished. So let's simplify this in sections. So let's focus our eyes in pieces. It's not bad if we focus in pieces. We just tested on this. Cosine of arc tangent of 1. So what does this mean? We have an angle where our tangent is 1, and we're only going to answer that on this interval, from positive pi halves to negative pi halves. So won't it be positive pi fourths? So we're now looking at, instead of arc tangent of 1, we're looking at cosine of pi fourths. What is cosine of pi fourths? Cosine is x at pi fourths, so what's that going to be, guys? So not only do we have that, we have root 2 over 2. Changing colors, that's going to be times 2 cosine of arc cosine of x. Now this is arc, focusing on this piece, arc cosine of x is not on our unit circle, correct? So this is when we drew a angle. We drew a right triangle, because that's what arc cosine means. We have an angle that has a cosine of x. So that's really x over 1. So cosine is adjacent over hypotenuse. So our adjacent side will be x. Our hypotenuse will be 1. So now it says find the cosine of that. So isn't our cosine just going to be x over adjacent over hypotenuse? So won't it just be x over 1, which is x, right? Does everybody understand? Now I found the cosine of that. So cosine is adjacent over hypotenuse, which would be x over 1. So we're timesing that by x over 1. So we just simplified that piece. Is everybody mentally there? Yes. Yeah, they did just cancel out, right? Because they're inverses, and so I just wanted to get us thinking about what it really means so that the next piece will be a little easier. Good questions. Okay, now moving on. So now we're going to have subtract, and we're going to simplify this in sections. I wish this wasn't squished. So sine of arc tangent of 1. We already know what arc tangent of 1 is. Look, back to here. We said it was pi fourths, didn't we? Yeah. So we're really looking at the sine of pi fourths, which is root 2 over 2. So that became root 2 over 2. And then times by, now right here's a little different. So we do have our right triangle, sine of arc cosine of x. So arc cosine of x isn't on our unit circle, so we draw a right triangle. So arc cosine means we have an angle whose cosine is x over 1. So our adjacent side is x, our hypotenuse is 1. Now it's asking us to find sine of that now. So sine is opposite over hypotenuse. So don't we need to do the Pythagorean theorem? This is what we did on the test 2 tests ago. So we would Pythagorean theorem it. 1 squared minus x squared equals the other side squared. So that would be 1 minus x squared equals question mark squared. So square root of 1 minus x squared equals question mark. So this is the square root of 1 minus x squared. So now sine is opposite over hypotenuse. So that would be root 1 minus x squared, which is our opposite side, over our hypotenuse, which is 1. And now we just continue to simplify it. So we're looking at this, simplifying that. So that's root 2x all over 2, isn't it? And then we have minus root 2, and then we can write this a couple different ways. We can also just write it as times root 1 minus x squared all over 2. Or we could put the 2 in, couldn't we? As long as we distribute it to both or use parentheses. I'm almost going to opt for this answer. So we can put this as one fraction now because they're both have a denominator of 2. So root 2x minus root 2 root 1 minus x squared all over 2. I'm almost going to opt for factoring out root 2. So that is root 2 parentheses x minus the root of 1 minus x squared. I factored out root 2 on top. So then left in this term was x, and left in this term was root 1 minus x squared, and that's all over 2. So that one was a lot to think about. I knew it was. Okay, this one, it says prove that this equals this. So you're using, it's a difference. Notice it's a difference, and it should simplify to be that. So we're going to say, okay, I'm going to focus on the non-simplified side and make it the simplified side. So we have cosine, cosine's the opposite sign, and then it starts with cosine, cosine, sine, sine. So we are looking at this. Cosine of pi halves times cosine of x plus sine of pi halves sine of x. Let's continue to simplify. What is the cosine at pi halves? Remember where pi halves is, right there. That's over 0 up 1. So isn't that 0 times x? So 0 times x plus, and then our sine at pi halves is 1. So 1 times sine of x. So this one's easy. 0 plus sine of x equals our answer, sine of x. So I just simplified it, because with 0 times x, 0. What's 1 times sine of x? Sine of x. So 0 plus sine of x equals sine of x. And we've proved what we were supposed to prove. Yes? Yeah. Wait, no. Yeah, it is. It is. Yes, but it wants us to show it using the difference formula now. Because this is kind of where it comes from. Okay, so with this one, it says simplify the expression. So we could do it, you're right, using one of our identities. If I said simplify the expression, oh no, this one isn't one of our identities though, right? So this one, we would split up and rewrite it. So this would be cosine of theta, cosine of 3 pi halves, plus sine of theta, sine of 3 pi halves. I'm just using that formula. And now we can simplify it. Cosine theta doesn't simplify. Cosine of theta. Cosine at 3 pi halves is 0, isn't it? So times 0 plus, I'm showing my work, sine of theta doesn't simplify. And then sine at 3 pi halves is times negative 1. Isn't sine at 3 pi halves negative 1? So that's 0 times cosine, which is 0. So we have 0 plus sine times negative 1 is negative sine of theta. So negative sine of theta would be our simplified answer. That's actually a really good one you could see on the ACT. Doing good. We're literally almost done here. We're down to our last 2 examples. So simplify the expression. Do you want to go for it, or should we just go for it and finish up? Okay, go for it by yourself. Go for it.
I got tangent to theta. Not just that.
What was that? Yeah, it would be under. Good point. Okay, we all got it?
Tangent to theta?
Tangent to theta.
Yeah.
Okay, awesome. Okay, let's see. We can't do this one before the bell rings for lunch, so we're going to call it good and then come back and let's do one example, and the rest of the time will be yours to do homework. So we learned last time how to solve a trig equation, and now we know how to solve a trig equation that looks like this, because we know our sum and difference formulas. So maybe write this down so you can refer back to it if you need to, real quick, and then we'll go for it. So we have sine of x plus pi fourths plus sine of x minus pi fourths equals -1, and we're solving it only on an interval from 0 to 2 pi. So we've got to rewrite this, and then we can look at it in pieces. So we're going to just focus. There's quite a bit going on here, because notice we can rewrite this piece. We can rewrite that piece. So let's rewrite that. So sine is, we'll do sine of x times cosine of pi fourths. We're just rewriting that the green box here, and then it'll be plus cosine of x, right? Sine of pi fourths. And then let's simplify that while we're at it. Any opposition to that? So we have sine of x times cosine of pi fourths, which is √2/2, right? And then we have plus cosine of x times sine of pi fourths, which is √2/2. Okay, now we have plus, and now I'm going to highlight this in blue because I can't fit it all, and do this down here. So we'll rewrite this as sine of x cosine of pi fourths minus cosine of x sine of pi fourths. Simplifying that in sections, so we have sine of x, √2/2, minus cosine of x, √2/2. So now I'm going to, and we have that equals 1. So let's continue to simplify. So that was addition in between. So we were adding this and adding this. So let's combine like terms here. So we have sine of sine of x √2/2, and then sine of x √2/2. So isn't there 2 of those? So we have 2 sine of x √2/2. And then we have our cosine x √2 minus cosine x √2. So don't those just happen to cancel out? So we're not dealing with anything too bad here. Equals -1. So that's what equals -1. So now we're really dealing with something very easy. Isn't 2 divided by 2 1? 2 divided by 2? Yeah. So we're really just dealing with sine of x of √2, because those 2's divide out, equals -1. So now isolate sine. So it was actually easier than it looked. So we divide both sides by √2. So we're looking for when does sine of x equal -1/√2, which is really -√2/2, because we would rationalize our denominator. So we have 5 pi fourths and 7 pi fourths is our answer. And it was only over an interval from 0 to 2 pi. So our final answer was x is equal to 5 pi fourths and 7 pi fourths. So I would have known how to solve that without actually rewriting this, simplifying it in sections and whatnot, but it was actually very easily solvable. That is literally it. So you can do the assignment now. Here it is. Go for it. I actually just realized we have one more lesson, and then a review, and then a test. So I had lied to you. I didn't realize there was one more.
That's okay.